Welcome to my tutorial, implementing a factory to create classes by name using the Unity application block. I'm Jeffrey MacArthur. So let's get started. So we've got Visual Studio open here, and what we'll do is we'll start from scratch, create a new project. And what we're going to call it is our factory demo. And this is a simple little console application that will demonstrate how to do this. Okay, so the first thing, we have to set up a couple of references. Obviously we're going to use NuGet to add a couple of references. And the first thing we're going to add is Unity. So we install the Unity application block, we accept the license, and it installs. The other thing we need to install is Log4Net. And we'll install Log4Net. Okay, so now we've installed our classes that are references that we need. The first thing we need to do is configure Log4Net. Log4Net it becomes very important when we're dealing with Unity, because we need it to figure out how things work. So the first thing you need to do is we need to add a line in this assembly info to set up an XML watcher for the Log4Net. So we'll copy and paste this from another. Okay, so what this does is this tells Log4Net to look for a file Log4Net config. Okay, so that's there. Now then, we need to add a new item, which is an XML file, and that is actually, if I an application configuration. It's an XML file, but it's an application configuration file, log4net.config. So we add that. The log4net is there. It's actually, probably should have just started with a XML file. Log4net doesn't use that configuration. I'm going to copy the Log4Net from one of the somewhat standard Log4Net configuration files that I use. So let's paste it here. The one interesting thing about this, notice this statement here, where this tells it to use the environment variable log4net for the path to locate the file, to locate the logs. This allows you to put the logs in a standardized place. I define that. Odd thing about this is that it is case sensitive. So it actually has to be log4net all in, as I've got it here, where it's all in uppercase. So this defines a logging pattern that will use the rolling file. This will use the rolling file appender and create up to 500 logs of 2K in size. We'll read up to a gig. It's sort of like I said, this is the standard one that I use on many things. It's there. The only downside to using the environment variable is if you're doing a website, because the environment variables are set when the server starts up, not IIS. And so you actually, if you change the log4net or set it, the environment variable, you basically have to reboot the server. You could go in and stop services and restart them, but it's almost easier just to reboot the server if you play with that on a web application. So now then, let's get to our program. So what happens is, one of the things we need to, first thing we should do is make sure that our logging is actually working. So let's, anybody who's used log4net, we need to, inside our class, we need to declare an instance of ilogger, of ilog, and what happens is that creates that. So now then we can do something fairly simple, like let's do our standard check if log.isDebug enabled, log.debug starting, and then we'll put one at the end, if log is debug enabled, log.debug, done. So now then, we can do a quick little test to make sure that our logging is working. So if we run this, notice it pops up and closes them almost immediately. But let's see if we're, let's open up and something isn't right, because if we're in our logs directory, it didn't log. All right, so what did we do wrong? So we've got assembly info, we've got the log4net, log4net. Notice the reason it didn't work is log4net's build action is none. We have to set the log4net to content, and we have to set the log4net to either copy always or copy newer, if newer. So I always do that. Now, if we, and let's go back to the program, do two other things that just make it a little bit easier. The console application, console.writeLine, done, and console.readLine. We can do read key or something just to give it something so that we know that we're done. So if we run this now, we actually do see, because we've got the console appender enabled also, it shows done. So we know that it logged the console, and we also notice that it created in our directory here our log file, which is here, which says starting and done. Okay, so now we can delete our log file. Let's minimize that. Okay, so we've got logging working. The next step is we have to get Unity working. So we've added Unity here, but we need to add, at this point in time, we need to add a new, let's add a new item, which is a configuration file. And, well, actually, let's just make it, it's actually just an XML file, since that doesn't save us anything by saying that. And what happens is we're going to call that unity.config. Okay, so this gives us a Unity config file, and what we need to do is we need to enable this in our app config. So we're going to set up the configuration sections here, and we add a configuration section which tells us that we're using Microsoft's Patterns and Practices Unity configuration, and then we use Unity config source, Unity config. So this will include it in there. So we have the Unity config file now. Notice again the build action isn't set, so we need to make that as content, and I do copy always. So that's there. But we've got to configure it. Now, one other issue with NuGet is NuGet doesn't actually install the schema for Unity config, which is very useful to have the schema. So what happens is, though we're in XML here, so we have to go in and we need to specify the schema. So we have to add the schema, which actually will be up a directory over in the packages directory, and there's the Unity configuration schema. There we go. So now we've got the schema enabled, and we can let's at least put the minimal configuration in here. So I'm going to copy, I'm going to copy the Unity configuration line, or the namespace line. So then we /Unity. So there we've now defined Unity, and we're not going to define a container or anything like that, but let's see if we're able to at least run. And it runs. Okay, that's always good. I always like to make sure things run. So now we've got the basic framework of a minimal application working. So we're going to add the first class, which is, we're going to add the interface to define the classes we want to be able to instantiate through the factory. So we're going to create an iThing. An iThing is a public interface, and it's going to have a string, description, get. So it defines a single property, description. Simple, easy to understand. So now we're going to create some things. We're going to create, let's go thing 1. Let's add another class. Let's do them all. Thing 2. And add class thing 3. So now then, apologies to Dr. Seuss. That's always fun. Public class thing 1 implements iThing. So now we can tell it to implement the interface, which puts this in here, and we can actually implement it as return thing 1. And we're going to do the same thing for thing 2. Public class iThing, and we implement the interface, and let's return two. And thing 3 is a public class. Class thing 3 iThing. And thing 3. Okay, so we've got thing 1, thing 2, and thing 3. Let's save everything. So we now have our things defined. What we need now is we need we've got the things. We still didn't instantiate Unity. Got ahead of myself. Let's get back to the program. We've only defined the logger, but we haven't actually defined we haven't initialized Unity. So what happens is we're going to need to create a instance of the Unity container, and this is here. So the Unity container, and we're going to call a method well, first off, we can resolve this issue because we're going to tell it that we're using Unity. And then we need to return Unity container, and this is the this class here. And this is a static because we're inside. So let's initialize the container. Now this is some code that I found and I use again in multiple applications I've implemented. So the first thing we do, let's get it so it resolves some of the issues. Oh, we need to add one more reference. We need a reference to system configuration. All right, because we need configuration manager. So we're going to resolve using system configuration. This creates an instance of the Unity container. Then we need to get a Unity configuration section from the configuration manager. We're hunting for the Unity section. If we get one and there's at least one container inside it, then we're going to configure it. If we don't, we get exceptions. We handle a couple of logging because if we make some typos in the Unity configuration file, this allows us to find out the exact errors that we've got in the Unity configuration file. So let's try running this. And this works. Okay, so we've actually instantiated that, but we're not doing anything yet. So let's start. Now we have some interesting work in, we could either start here with Unity or we could start creating the factory. Let's implement the factory. Then we'll set up the Unity configurations. So what we're going to do here is we're going to this is the factory demo. We're going to add another class, which is, let's call it the class factory. No, it's a thing factory. Thing factory. So, thing factory, and it's a public class. Public class. We're going to need in this one, let's add a log4net, an instance of log4net, and so we have log4net. Now we're going to need to Unity knows how to create any class that Unity knows how to resolve. It also knows how to create a factory for that class. So we're going to need an instance of the Unity container, but we don't want to create that here. We want to have that injected. And we're going to use property injection. So let's do private iUnity container. So it's not going to container equals null. So we're going to first off create a field to this is a private field. Now what we're going to do is then we're going to do a public func iUnity container, func Unity container, and this is a public with a getter and a setter. And then we define our protected, though we're not, this is the normal way I would do this, is to make this one as protected. This is an iUnity container of container, and this implements just the getter. And what we're going to do is we're going to return the container. But the test here is if, let's go to the colon, if the container is null and the func Unity container is not equal to null, then we're going to say container is equal to func unit, that we're going to invoke the function to create the Unity container. So this will set that up. So now then we can create a public iThing, which is to, we're in the thing factory, so it's called create thing, and pass in a string of its name. And again, we need an I thing, a thing which is equal to null. And eventually we're going to return thing. So at this point in time, this is how we do we're going to resolve and construct the thing. So what happens is, if the container is not equal to null and container dot is registered I thing, and this is where we pass the name, if it's registered, then we're going to do thing is equal to container dot resolve I thing with name. And let's handle the else condition. Else, and we're going to do string G is equal to unable to resolve I thing and then we're going to do if log is error enabled, error G, and then we're going to do a throw new exception. So if we can resolve the thing, we will return it. Otherwise, we'll throw an error exception. We could actually just return null. That's something we'll explore a little bit later. So now then, we have a class that will construct this. So how do we use this? So what happens is we can go back to the main program. Where is program? There we go. So inside here, we're going to create a thing factory. Is equal to container dot resolve a thing factory. Resolve a thing factory. So that will create the thing factory. Then we can do an I thing is equal to thing factory dot create thing, and let's say thing 1. Now that's not the name that we can name the class, which we'll talk about in a second. But if we run this, we'll get an error because it doesn't know how to resolve thing factory yet. So unable to resolve. Notice we got the error unable to resolve, and we threw the thing. We actually resolved the thing factory, which was interesting, because that's one of the new features of Unity 3 is it knows how to resolve certain things by convention. But let's go back into manually. So let's start off and do some, let's define our aliases and define our container. So since we so the first thing we're going to need is we're going to need an alias, and the alias is an I thing, and the type is equal to factory demo dot I thing, comma factory demo. So that will define the interface in the alias for the interface. So let's define the rest. So that's thing 1, thing 2, thing 3, and this is I thing 1, thing 2, 3. Let's delete that, and there we go. So that defines the aliases for the things. We should define the alias to be complete. Alias for the thing factory, and the type is equal to factory demo dot thing factory, and it's going to be factory demo. So now we've defined all the aliases. Now let's start defining the container. So the container. So we're going to register type iThing, and it maps to thing 1 with a name of thing 1. So this was where we can use different names than the class names. So this is thing 2 and thing 3. Thing 3. Now then, let's register. What we should do is register type of thing factory. And we don't need to map it. We're just going to register the type, and we're going to do this is going to use property injection. Property name is equal to, and thing factory. This is where we inject the func unity container here, and we'll do that. So now, if we run this, starting done. Why did we get starting done? Because oh, because we created the thing, but we didn't do anything with it. Ah. So now then, that's why it actually worked. Console.write line of thing.description. All right. So now if I run it, you notice it writes out thing 1. This allows us to do some more interesting things. So what happens is if at this point in time, I could do for each string arg in args, and then we use arg, and we change the properties of here to pass in here. So if we pass in thing 1, and we run this, notice it works. But it also allows us to do things like thing 2, thing 3, thing 1. And notice it. So we're creating the object by class from the property passed in from the command line, and we're not using directly any reflection. We're letting Unity do all the configuration, everything like that. I was going to show, if I go back to the Unity config, let's make a typo Let's just delete the G there. I made a typo, so it doesn't know what to map to. And now if I run it, notice I get a bunch of error I get this. This is where the log, it becomes important to have the log be sweet. So now if I open the log, you notice through exception, thing 2 could not be resolved. So it tells me exactly what couldn't be resolved. So that's the reason why logging is so important for when you're dealing with this, particularly when you're dealing with it. So if I make this thing and then we save everything and run it one last time to make sure it's all working, then it's all working again. So now I will put the sources up on my blog and write this up. But thank you for listening. This was interesting to get going. So we'll see how this works.